Welcome to our channel Euclid Mathematics. We have started lecture series on previous year question from JEE Advanced Exam. Within that, I already uploaded plenty of the videos on my channel. So if you wanted to see this video, you may check it into my playlist. Now here in my today's video, I'm gonna explain to you all one of the question which is from JEE Advanced. And one thing is here, all students, that I'm uploading all latest previous JEE advanced question paper solution. All are the latest because you all need to be familiar with the previous year questions paper which is coming from the latest JEE advanced question paper. So questions are quite easy. That just we have to apply little bit a concept and most of the calculation part is there. So if you can understand this question properly, that you are able, you may solve this question easily. Okay, now let's get started our today's question which is from JEE Advanced. First of all, I'm going to explain to you all the question and then we'll move for the solution. We have given f is a real valued function. That means f is mapping from f which is from real number to the real number. Okay, that means all the domain which contain whole real number and codomain which contain whole real number. Okay, that means all number is coming from domain and it lands to the codomain. But the relation between this domain to codomain, we have given function, and a function it is here given in the part of 4 different function. Okay, for every different value of x they define 4 different function. So when we have x is a smaller than 0, then they define here one function, that is x raised to 5 plus 5x raised to 4 plus 10x cube plus 10x square plus 3x plus 1. Okay, this one is the first function which defined for x strictly less 0. Now second function it is defined for the value between 0 lesser equal x and strictly less 1 is x square minus x plus 1. Now third function it is defined here over real number to real number on interval 1 lesser equal x strictly less 3. So the function, third function here, 2 by 3 x cube minus 4 x square plus 7x minus 8 by 3. And fourth and last function for the all value for x greater equal 3, that means the x can take all the value from 3, 4 and so on till infinite value from real number. Okay, so these are the 4 functions we have given, and then we have to find out, figure it out which one of the 4 options are correct. Okay, so question is from the paper number 2nd, that means we can say here 2 or more than 2 options are correct. So we have to check each and every option very carefully. Now let's check each and every option what we have given in our option. So first option it says that f dash has local maxima at x which is equal to 1. Okay, so first derivative of a function f has local maxima at x which is equal to 1. Now you may think here that we have given 5 different functions. So we may given 5 different functions. So how can we define a single f for a f dash? Okay, so that I will explain in the option directly. So here we have f dash has local maxima at x is equal to 1. First option given. Second option says that f is increasing on open interval minus infinity to 0. So f is increasing, that means when function is increasing their derivative is bigger than 0, then we say that function is increasing. Okay, so we have to apply that concept here on closed interval negative infinity to 0. Okay, and the third option we have over here that f dash is not differentiable at x which is equal to 1. Okay, that means f do not possess differentiation at x which is equal to 1. Okay, and the first option it says that fourth option it says that f is a onto function. Okay, so don't get confused when you see like onto function, one function, into function, many one function. These are the quite easy definition that we need to remember one or two short word to apply these concepts. Okay, so now let's get started on today's question solution. I'm going to explain to you all each and every option in detail with their definition and basic concept too. Let's get start our solution. So here we have given real valued function mapping f from real to real. Okay, and a function it is defined over here. Okay, so this is the function which we have given in our question. And for finding onto function is increasing or local maxima exist or not, so we need fx and f dash of x, maximum f double dash of x, not more than this concept we needed here. Okay, just we have to find out their first differentiation, second differentiation, and then need to apply some basic concept here. Okay, Now here in our polynomial function, so here first polynomial function, second polynomial function, third polynomial function, and fourth polynomial function. We have given four polynomial function. We can directly find out f dash of x, f double dash of x, or we can directly define our option here in our four different function. But as I felt that whenever you found such a bigger term, like these many terms like in the 4 3 2 1 power, okay, it's look quite bit difficult or confusing to understand. So to apply the concept onto this is quite bit confusing over here. So try to reduce our polynomial function, try to take their square, take their shortest form, that easily we can define our option for this one. Okay, so here we can see these are the standard form are given, so no need for more adjustment. So x raised to 5 4 3 2 1 it is given, plus 1 0. So this is the some type of the nth power of some polynomial. Okay, so we can write a 3x as, so instead of a 3x if we take a 5x, then we can easily say that so it is having some power of some polynomial. Okay, so I written here shortest form here. Okay, in my next step, that what I have done, I replace 3x by 5x and a minus 2x added here. Okay, so in order to maintain our original term. Okay, so the value for x strictly less 0, it will remain same. So similarly it is for the other three polynomial. Okay, so other three polynomials I did it here. So keep go for the next calculation for x square minus x minus 1. So what I have done, multiply 2 divide 2, because of that this is the square for some type of the certain polynomial. Okay, so x square minus 2 into 1 by 2 multiplied by x plus 1 by 4 plus 3 by 4. Okay, okay, just what I have done, just one written as 1 by 4 plus 3 by 4, because of that a square minus twice of ab plus b square it is coming, so a minus b square, that polynomial it is here. Okay, so that's why we can reduce this term more shortest form, that's why I written this way. Okay, and then here it is the final steps that can be shortest form of our given 5 polynomial, that means x plus 1 raised to 5, this is the fifth power of x plus 1, this polynomial here. Okay, and even if you don't know how to find their fifth power, you may apply binomial theorem. Okay, that you will get it easily. But even after, if you found difficult, you may go for the directly finding option by using this polynomial, no need to come for this step. Why I explained to you all this step, because I wanted to make our example more shorter. Okay, I wanted to make example more simplest and more shortest. Okay, okay, that is it's easy and crisp, look crisp or crisp. Okay, so that's why I written x plus 1 raised to 5. It is the expansion for this term. Okay, minus 2x as it is over here, and the x which defined for this polynomial as strictly less. Okay, x strictly less 0, that means this polynomial can define over all real number, but the only condition is here x need to be smaller than 0. That means the value for x which can take here minus 1 minus 2 minus 3 up to minus infinity from real number. Okay, so these are the value for x it is coming. So now second polynomial, it is here x minus 1 by 2 bracket square, so it is a square for first polynomial, plus 3 by 4 as it is, and 0 lesser equal x strictly less 1. Okay, so here is the square for the second polynomial I written here in the short form, and third and fourth both polynomial I kept it same. Okay, so these all are the function. Okay, these all are the function from our mapping here from real number to real number. Okay, that means whenever we take any element from the real number and we apply to this function, that will get the real number itself. Okay, so meaning for that mapping here, don't get confused, this is just a domain and codomain, that we have to apply the value over here from the real number domain, and then we'll get the value for codomain. Okay, so all these values over here. So now here we can see we have first polynomial, second polynomial, third polynomial, and fourth polynomial. Now here we can see that it seems like that some variable are having some fixed values. Okay, so we cannot say that what is the value for x here, there are infinitely many value. But in our second polynomial, at x which is equal to 0, that polynomial defined here. Okay, x which is equal to 0 and bigger than 0, but we don't know bigger value, so we are sure here that we get the x which is equal to 0 for this polynomial. Okay, That means whenever we get the x is equal to 0, we define this polynomial. Okay, whenever we get the x which is equal to 1, we define this polynomial. Why x is 1? Because the value for x, the polynomial which taking the value for x is a 1 or bigger than 1 but not 3. Okay, smaller than 3. So it is one thing is sure here, the value for x is a surely 1 here. Okay, and those value we are sure about this, so we have to take these ones. Okay, so I got the x0 x1 from these two polynomial, and exactly here x which is equal to 3 we got it here, 3 or bigger than 3. Okay, but we don't know the bigger value for x, so that's why the value which we are confirm here, so we have to select this one. Okay, so x which is equal to 3, which is a confirm value for our third polynomial, so I got the x is a 0. For x is equal to 0, then we get the this polynomial f of x. Okay, now put x is a 0. When x is a 0, what we will get? 0 minus 1 by 2 bracket square. Okay, so what we will get here, let me explain. When x is a 0, what the polynomial gives us? 0 minus 1 by 2 bracket square plus 3 by 4. Okay, now 0 minus 1 by 2, negative 1 by 2 bracket square means positive 1 by 2 plus 3 by 4. Base is same, 4 by 4, so our value gives us 1. Okay, so whenever we select x is a 0, we get the function f of x gives the value 1. Okay, what the f of x gives value? 1. Okay, now second condition here for the first polynomial, whenever we choose x smaller than 0. Okay, whenever we choose x smaller than 0, then let's find out whatever the value our first polynomial gives us. Okay, now let's see here. So by doing this, let me select some of the point for x which is smaller than 0. So -3, -5, -50, anything you may select. Okay, so x smaller than 0, so I select x which is equal to -5. Okay, so select the value that can be middle. Okay, not much smaller, not much bigger, that can be visualize our polynomial. Okay, so whenever x smaller than my x is equal to -5, why I select x -5? Because x is smaller than 0, so you may select any value. So for your better understanding, I selected here -5. So put x is a -5 in our first polynomial, and then find it out what our polynomial gives us. Okay, so if x is a -5, so -5 plus 1 bracket to the power 5 minus 2 times -5. Okay, now so -5 plus 1, so 1 minus 5, it is a -4. Okay, minus 2 to the power, sorry, 2 multiplied by negative, it is positive. 2 pies are 10. Okay, so it is power 5 here. Okay, now here we can observe here. Okay, so here we can observe, so what I have done, I just taken the x as a -5 in our polynomial. Okay, that is a minus x here, x plus 1 raised to 5 minus 2 times x. Okay, so x I selected here -5 plus 1, so 1 minus 5 minus 4 to the power 4, minus plus 2 5s are 10. Okay, so here we can see we have odd power of a negative number. Okay, so whenever we have negative number to the power odd, we always get the negative number. Now let me explain one more time. So whenever we have positive sign to the power any number, odd, even, so we always get the positive. Okay, but whenever we have negative number to the power odd sign, we always get the negative. Whenever we have negative number to the even power, we always get the positive. Okay, so what we can do, let me explain with the one example. So if I consider -3 to the power 3, so how can we write -3, -3, -3 3 times? Okay, so that means negative positive 9 multiplied by -3, so -27. So it represents that 3 odd number gives negative to the power negative. Okay, so -4 to the power 5. Okay, it will be negative, but 4 to the power 5, that means 4 to the power 5, it is obviously bigger than 10. So here we can see we got the -4 to the power 5 is a -1024 plus 10. Okay, so this term will give the negative answer. Okay, so -1024 minus 10, so -1014. Okay, so you may see that whenever we increase negative term, that -5, -6, -7, that term it will be go smaller, like a negative of 1000, negative of 10,000, negative of like this. Okay, so this term approaches to negative of infinity. Okay, this term approaches to negative of infinity whenever we increase that x. Okay, Try to understand, nothing is difficult here. Just I wanted to explain to you all for what value of our polynomial define. So if I consider here the value for x which is a more bigger than -5 or more smaller than -5, what value our polynomial gives? So I selected x is a -5, so my polynomial f of x gives me -1014. That means 1014 it is given, okay, negative of 1014. That means the value for x it is goes more bigger than negative, like a -7, -9 and so on. The value for negative it will be -1000, 10,000. The value it will be raise and raise, okay, it will go more bigger. So the meaning I wanted to explain to you all here, our f of x which is a decreasing to negative infinity, that means it goes to smaller and smaller, then we say that the in quantity getting decreasing, okay. So our f of x is getting negative, negative, negative for every point, and it is a more bigger value. So more -1021, it is the for x which is equal to -5, we got that, okay. So this value is a more smaller than -5, okay. So whenever in term we take negative, the value quantity getting smaller and smaller, okay. So this is smaller than, more than this -10,000 is smaller, and then so on, okay. So whenever we increase decrease x, we get the more smaller value for f of x. That means f of x is a decreasing to negative infinity, that means that value approaches to negative infinity, okay. That means our f of x gives the value from negative infinity to open close interval 1, okay. That means we don't know the end point, what the end point will give us, okay, but we know that the other point will give us a 1, okay. Okay, so the value for f of x we have for x smaller than 0, which is a on that interval negative infinity and 1, okay. Now let us see, we have one more condition for x which is equal to 3. So whenever we select x is a 3, we get the f of x as x minus 2 log to the base e of x minus 2 minus x plus 10 by 3, okay. I already explained earlier this part, okay. So now when x is a 3, then check out what the value for f of x gives us. So here we can see when x is a 3, f of x is gives us the value for put 3 minus 2 1, 3 minus 2 1 log 1 0 minus 3 plus 10 by 3, which is a 1 by 3, okay. 3 minus 3 minus -9 10 minus -9 by 3, okay, which is a 1 by 3. So whenever I select x which is equal to 3, I got the f of x is a 1 by 3. But we have choices for x which is a 3 or bigger than 3. That means next time I may select x is a 4 also, x is a 5 also, 6 7 and so on, okay. So next time I may select any value between this, okay. The value for x whenever increase, our f of x it will be go bigger and bigger, okay. That means whenever x taken bigger than 3, f of x increases and it increases to plus infinity. Now select x as a 1 lakh, take one of the big element and now check out it. The calculation is quite difficult, but my point is here, our f of x gives a bigger value, okay. And if x is a bigger and f of x gives us a bigger value, then our f of x is here increasing, okay. So you have to understand the definition for increasing function and decreasing function, then you can solve this one, okay. Nothing is difficult here, okay. Now if I combine the case number second and case number third and case number first, okay. So the value for case number first, we got the x is a f of x is 1, when x is a 0 f of x is 1. When x is a smaller than 0, I got the interval negative infinity to 1, okay. So when x is a 0, I got the f of x 1, okay. When x is a negative infinity, okay. So x is a 0, I got the f of x 1. X is a negative infinity, goes to negative infinity. F of x gives the value negative open interval negative infinity close interval 1. And when I select x, the value for x is a bigger than 3, okay. Then I got the interval for f of x is a 1 by 3. So here it is the interval. I hope you all have understood that interval, okay. Okay, now this 3 interval I got the using our function, okay. So if I combine all our given 4 function, that all four functions define on these intervals. Okay, so that means negative infinity, so close one included here, so 1 included here means 1/3 also coming here. Okay, so negative infinity to infinity, this belongs to negative infinity to infinity, this one also goes to there, and this one is also goes to here. Okay, that means our f of x, our four polynomial function f of x, which define here in this interval. Okay, negative infinity to infinity. And negative infinity to infinity in mathematics, we call it as the real number. That means real number is one of the biggest number, that we do not have big number than real number. Okay, so complex number is there, but we are learning the concept from real function chapter. Okay, so we use real number as bigger number here. So minus infinity to infinity, which is a real number. Okay, so it seems like that our function can take the value from real number and gives us a whole real number. Okay, function can take the value from real number and gives us a real number. Okay, and the definition for onto, you all need to know the definition for onto. Okay, now let me explain the definition for onto here to you all. Okay, so onto function, what it is mean by onto function? So if we have this domain and this one is a codomain. Okay, so mapping from A to B. Okay, I'm explaining here the definition for onto function. Okay, so whenever we have the mapping from A to B, the onto function, it says that the all element from B, all element from B, so any element you select from B will get the pre-image for that element, every element. Okay, so onto condition say that we want all the element over here that need to be a pre-image in A. Okay, so whenever this condition hold, then we say that our function is onto. Okay, understood definition of onto function? And onto function also called as surjective function. Okay, one function called as injective, and onto function called as surjective, and one and onto function called as bijective. Okay, so we are looking for only onto function, so I'm not going to explain to you all other definition. If you wanted to see this definition, check it into my playlist. Okay, so the definition for onto function, it says that the all element from codomain, we need a image in a pre-image in a domain, then it exists a onto function. But if we found any element over here, okay, any element over here we found that do not have pre-image, then it is not onto function. Okay, so keep in mind this one. So we have to apply this condition over here. Okay, so combining second and third, we get the f of x defined on real number. Okay, and our fourth option, it says that f is onto. Okay, if f is onto, that means whatever the value from domain we take here, we get the codomain full real number. Okay, so here we can see, we know that f of x, the image for f of x gives us a value from real number. Okay, so here we got the whole real number. Whenever f of x, it is remains same, that four function. Okay, these are the four function over here. Okay, so all are the four function here, all are the four function over here. Okay, and whenever we apply the values from real number, that all four function gives us f of x belongs to real number. Real number means minus infinity to plus infinity. Okay, so these are the value from real number. So if we apply the values from real number to our f of x, it gives us the values from real number itself. Okay, so it says that every element from real number, okay, it seems like that every element from the range or codomain, it is having pre-image over here. Okay, real number to real number, then f is a onto function. Okay, I hope you all have understood, because already we got the codomain as a real number, and already I know we have considered domain as a real number. Okay, after consideration of a domain as a real number, I got the codomain also real number. So the mapping between these two domain and codomain, it is completely real number. So f is a onto function over here. Okay, now let's go for the next further option. By using f of x, you have to understand how can we find the f dash of x. Okay, so first polynomial function x plus 1 raised to 5 minus 2x is there, so differentiate it once, then we'll get the n x raised to n minus 1, and differentiation of a 2x is a minus 2. Okay, similarly differentiate other functions. Okay, polynomial function, I don't think so is anything difficult for differentiation of these. Okay, as if you solving the question from JEE Advanced, this basic concept you need to more perfect. Okay, so this one is a f dash of x. Okay, so here it is f dash of x. Now what we want here, f dash of x is not differentiable at x which is equal to 1. Okay, now let me explain first of all the definition of f differentiable function. Okay, if I wanted to show f of x is a differentiable at x which is equal to 1, so what I do, limit as what I do for the differentiation, limit as x tends to 1 plus, which is a right hand differentiation. Okay, f of x, f dash of x is equal to limit x tends to 1 minus f dash of x. Okay, that means the left hand for f dash of x, instead you take f of x plus h minus f of x upon h. Okay, this is the rule of a differentiation that we call first principle for differentiation. So if you wanted to show any function is a differentiable, that we show the right hand limit for differentiation and the left hand limit, that means x tends to 1 plus and x tends to 1 minus, both are equal. When both are equal, then we say that function is a differentiable for that particular point. Okay, so now we have to show f dash of x is a differentiable, not a f of x is differentiable. Okay, when we show f of x is a differentiable, that we show limit x tends to some certain point c, f dash of x. For f of x, we show that f dash of x which is equal to limit x tends to c minus f dash of x. Okay, this is for function differentiable for f of x. Okay, so if we wanted to show f of x is a differentiable, then we show this one. Okay, when we have to show f of x is a differentiable, then we show limit x tends to c plus f dash of x, which is a right hand limit for our differentiation, and limit x tends to c minus f dash of x, which is a left hand limit. Both are equal, then we say that f of x is a differentiable. But in our option, it is quite trickier, that they said f dash of x is a differentiable. If f dash of x is a differentiable, that means you have to show limit x tends to c plus f double derivative of x is equal to limit x tends to c minus f double dash of x. Okay, now we know that f dash of x. Now we have to find out f double dash of x. Apply x tends to 1 plus. Now c has given 1 plus and c has given 1 minus. Okay, and we have to prove this condition. I hope you all have understood. It is little trickier, that's why I taken this one. Now here main target, we have to define a function. Which function for we select here for x is equal to 1 plus and 1 minus. Okay, so we have to select the 1 plus and for a right hand limit and left hand limit for 1 plus and 1 minus between these four function. Now here we can say that see that here first second function involvement of the value for 1. Okay, so it is here, and second one it is here. So for 1 minus, we select 1 minus this 2x minus 1. So that means 2x minus limit as x tends to 1 minus f dash of x, I will select here 2x minus 1. Okay, so f dash of x will be 2x minus 1 for 1 minus. Okay, but we want f double dash of x here, so f double dash of x will be differentiation of d by dx with respect to this. Okay, 2x minus 1 is having differentiation only 2. Okay, so we'll get the 1 minus as a 2 only. Now for the 1 plus, it is the bigger value we always consider for 1 plus. So differentiate it 1 times. Okay, this is f dash of x, and we have to show f dash of x is increasing, so we have to show f double dash. Okay, so f double dash means 2 into x minus 2, n minus 1 means 2 minus 1, which is 1, and minus 1 is a 0. Okay, so 2 into x minus 2, limit x tends to 1 plus 2 into x minus 2. Okay, this is the way to find out the values. Okay, left hand limit and right hand limit by using these two functions. Okay, the involvement of 1 here we have and here we have. Okay, now let's find out the answer. So here I explain x tends to 1 minus f double dash of 1. I got the value for it 1, and it is not a differentiable given. If x is equal to 1, it is not differentiable. That means their differentiation not left hand right hand differentiation not equal. Okay, f double dash of 1 at point 1, I got the 2. F double dash of 1 at point 1, I have to find out 4 into x minus 2. It is double differentiation for f double dash of x. Okay, now put x is 1 here, so limit x tends to 1, 2, it will remain same because it is a constant quantity, it will remain same. And again apply 1, so 1 minus 2 minus 1, which is equal to into minus 1 into 4, which is a negative 4. Okay, so f dash is a not differentiable at x which is equal to 1. Okay, because left hand differentiation, right hand differentiation varies over here, it is not equal, and if it is not equal, our function is not differentiable. Okay, so our four polynomial functions are given. they are not differentiable. Okay, for some certain values polynomial it is always differentiable. Okay, but for the value for one polynomial is not differentiable. Okay, so here our function it is not differentiable for one. Okay, but always remember polynomial is differentiable for other than all point other than one. Okay, so this thing you need to remember. Now option number B is given f is increasing at minus infinity 0. Okay, so this one is a very easier. Okay, we have to apply the definition from the increasing function. Okay, and when we say that function is increasing, when first differentiation of a function is bigger than 0. Okay, so f dash of x is bigger than 0, then function is increasing. F dash of x smaller than 0, that means function is decreasing. Okay, this condition we have to apply over here. Okay, now here we can see I solved it here already. F is increasing on negative infinity 0. Okay, so here for x smaller than 0, we have to select the negative infinity to 0. Interval is given smaller than 0, that's why we have to take x is smaller than 0. For x is smaller than 0, you will get the f dash of x, this one. Okay, because f dash of f is increasing, that means f dash of x bigger than 0. So we have to deal the value for f dash of x only. So for x smaller than 0, I got the f dash of x over here. Okay, so f is increasing, that means f dash of x smaller than bigger than 0, that means f dash of x bigger than 0, that means this whole quantity bigger than 0. If this is bigger than 0, take negative 1 here, it will become positive. So we have to verify, can this property hold for the all values of a negative infinity to 0? Okay, so for some certain point this value may be hold, but we don't have any business with these values. We want the counter value that can discard our option. Okay, so for that particular point I selected here, I select here x as a negative 1 from the negative infinity to 0. Okay, so negative 1 it is always belongs to that open interval. Okay, so the value from 0 but not 0. Okay, lesser than 0 but not 0, all values coming from this interval, so negative 1 it is here. So put x is a negative 1 in our value. This one is negative 1. So negative 1 plus positive 1, it becomes 0. 0 to the power 4, 0. So 5 into 0, 0. So I got the 5 into 0 is 0, is bigger than 1. So can it possible 0 is bigger than positive 1? It is not possible, because 0 is smaller element, but it gives us a contradiction condition. So our option number B, it is increasing saying that, but it is not increasing, it is a decreasing function. So option B is wrong. Even after, if you do not understand this, let's see one more part for this, another solution for this one. Okay, so you will get the value for x by using this one. Okay, so I found it here, the value for x is here. X is a plus minus 1 by 5 raised to 4 minus 1. Okay, this is just a finding the value for x. So we can see here I got the value for x is a negative 1 plus 1 by 5 raised to 4, negative 1 minus 1 by 5 raised to 4. Okay, two values for x, I got it here. So f is changing its nature for different values, so we say that f is not increasing. Okay, it is a wrong option over here. And now last option we have here, f dash has a local maxima at x is equal to 1. Okay, so we have to take the polynomial which associated with the value for x is equal to 1. Now we know that the polynomials second and third, these only two polynomial associated the value for x is equal to 1. Okay, and we have to find out the whether it has local maxima or local minima or other condition. Okay, so we have to go for a stationary condition, it is there, or local maxima is there, or local minima. Or you may plot the figure, you may draw the graph. As you can see in my screen, I've already drew that graph. You can see there that a maximum value which represent a maximum value for x which represent is 1. Okay, so our option first is true by using this. Okay, and we have to plot these two graph. Okay, 2x minus 1 and 2 into x square minus 2, x minus 2 bracket square minus 1. Okay, we need to plot these two graph first. Once we plot that graph, we have to find out where the maximum point lies in. So the maximum point which lies in our graph at x is equal to 1, you can see there in a graph. Okay, so for plotting the graph, if you don't know how to plot the graph, you may check it into my playlist. Okay, I already explained how can we plot the graph. Okay, so already I plotted so many graphs in my playlist. Okay, so you may check it is there. And here one more, so if you don't know, then you may consider first function y is equal to 2x minus 1. Put the value for x, you will get the value y, and put x and y coordinate in xy axis, you will get the these two lines. Okay, once you get the line, find out the maximum point where it is lies, and that certain point for x which is the local maxima. Okay, so option A, which is a true over here. Okay, so I hope you all have understood my today's lecture. It is very easy to understand. Nothing is difficult here, just there are some of the application part of differentiation which is used over here. So I hope you all have understood everything. Even after, if you have any difficulty doubt, let me know in comment section. I will come up with this one more videos. So thank you everyone. Thank you for my today's lecture.